Uh, at the same time, I want to welcome everyone here present tonight. To today's class, we are we shall be looking at a more detailed area. We just introduced chemoinformatics. We did introduction to chemoinformatics. We were able to expose us into some of the databases available for chemoinformatics. But today we are going to now start practicing some of them. What we just did previously was an overview, a rundown of what these database are and what we can do with them. So, but then today we shall use them. Now, a quick one. All the chemoinformatics database are broadly classified under two categories. We have the ones that are that the datas are deposited. Like PubChem, the datas are deposited. Then there are ones that no data was or were deposited in this database, but then they operate based on algorithms. We have been so familiar with SwissAdme and PubChem. PubChem is a deposited database where if you are searching with PubChem, if you search for any record that is not found in PubChem, it will tell you that zero result found, meaning that it was not deposited in PubChem. So, and then if you are searching with SwissAdme, of course SwissAdme uses the smile code, so there is no stored data in SwissAdme. Once you put in your smile code, what it does is it will understand the chemical properties of the structure and generates all the information you need on that structure, the information that has been programmed for it to generate. So that one is working based on computer algorithm. If you look at SwissAdme, it is so empty. There is no stored data there, but PubChem has stored data. So we're going to start with phytochemical database. So we'll begin with phytochemical database. These are database that has stored information of plant bioactive compound, because I noticed that recently most of our research is geared towards the use of plants, and this in silico approach will involve you sending data into the system. So what kind of data do you want to send? Of course, these data are always structural data, so we can use phyto for the chemical database to get the structural data of our plants. Because if your work is designed on plants, you're using plants, that means you need the structural data of those plants, because whatever a plant can do is as a result of the bioactive constituents of that plant. So if as we all know that soursop can be used to treat cancer, it simply means that if we want to do this docking, so we need those compounds present in soursop. So we now have to look at some phytochemical database. Without this database, in fact, or before the database came in, what was there was chemical characterization, where you have to extract your soursop leaf using multiple solvents. Yes, using multiple solvents, not less than 10 solvents that are of different polarity, because the extraction is based on polarity. Polar solvent extract polar compounds, non-polar solvent, extract non-polar compounds or solutes. So you used multiple solvent because we don't know the exact compound in the soursop that is responsible for that anti-cancer activity. So we want to characterize it to find out, maybe want to, our interest is to get a drug, since our soursop is effective in cancer. So there could be a compound in that soursop that is very good against cancer. We can get that compound and use it and come up with a new drug. So if that is the goal, we that means we're going to establish a library of compound. Getting that library means we're going to characterize so much using different solvents. So that was the traditional method of getting the bioactive compounds of a plant. After that time, we move to the second stage. So if your idea is on plants, I will suggest you do this. Like me, I do perform a characterization with multiple solvents because that will give me good information of enough compounds present in the plant material. But if you cannot do that, if you cannot be able to perform the characterization, then the second approach for phytochemicals is to look out for already published work, because this characterization is not new again to us, and in fact some persons will tell you that there is no compound that has not been characterized. So you go online, download journals PDFs of characterized of that your plants of soursop. Download journals that talks about chemical characterization, either using GCMS or the use of HPLC or LCMS, although LCMS is the same thing as HPLC. So you characterize, you get people who have published work on that characterization. You gather their results and be able to compile the bioactive compounds present in those journals. So that is the second way of getting bioactive compounds in a plant, and this approach is called literature mining. So we can mine literature, and we done at least 50. We mine at least 50. So if we are going to mine literature, we mine at least 50. So 50 we will be okay, because we want to get enough bioactive compounds in the plants. So we want to get enough bioactive compounds in the plant. So if you want to get enough bioactive compounds, they are going to scout for more, search for more, and compile it. In fact, once you have compiled it, you just created your own personal database of bioactive compounds of soursop. Yes, because once you have been able to gather information and store to a place, what you are doing is you are creating database. So but the third approach for phytochemical data, the third approach to get phytochemical data is by the use of database. So let me start with the first one, MPAT. So quickly, let me share my screen. Quickly so that we can be able to follow up. So I will start with the first one, MPAT. Now, what this database now are doing is that they are actually compiling the first and second approach together and build a system that has these bioactive compounds. So can you see my screen?
Yeah.
All right. So what this like impact database is a phytochemical database. So the idea behind this database is owned by Indian. This one is owned by Indian. I will show you one owned by American, which is Dr. Dukes. Then I recently stumbled into one owned by Nigeria. Some persons did a research with Ted Fund, and the Ted Fund granted them access, and they did a database for Nigeria. But it's so funny, Sha. I will show you by the end of the class, so that you will see the need for us to actually take chemoinformatics serious when it comes to drug discovery and other aspects. So this is MPATS. MPATS is a phytochemical database that has about 4,010 medicinal plants. It has 4,010 Indian medicinal plants. So these people, they did the first and second approach, and it has 17,967 phytochemicals. So broad. Is owned by Indian. How did they come about this? They consulted about 100 books on traditional Indian medicine. The same thing we are going to do for Nigeria. They compiled about more than 7,000 published research articles. Like I said, those research articles on bioactive compounds, they search for them. But we are going to do our own. Each person will be searching for no less than 50 bioactive compounds. Like if each person will have like 5 plants, and in that 5 plants, you are going to search for at least 50 journals that has information on the bioactive compounds. Because if we are doing docking, when we get to docking, we don't dock with less than 100 compounds. So we need library. We need library of those compounds. So this is MPATS. MPATS has 2 parts. You can use it to know the phytochemicals present in a plant under the Phytochemical Association. You can also use it to know the therapeutic use of a plant. Maybe you have a plant, say sub 2, and you don't know the kind of disease that sub can be able to treat. Indian has developed a database that can tell you that. So far, I've not seen any phytochemical database that can equate MPATS. I've not seen. So how do I use MPATS? Remember, the idea is to get bioactive compounds from my plant. I have consulted characterization. I have downloaded literature. I need to also mine database. So by the time I gather all the compounds from my characterization, from my literature mining to my database mining, I'll be having enough bioactive compounds. Although some of them will be repeating because it's the same plant. Some of them you got from your characterization might still be some that you see in the works that have been published online. And it may also be similar to the same compounds must also appear in the database. So, but then we are not saying that exactly the same thing will appear. But by the time you gather all and then remove your duplicates, you must have gotten enough. So quickly, what you just need to do is to come to this white space and click. Once you click on that white space or this drop down arrow, it will bring out a comprehensive list of bioactive compounds arranged in an alphabetical order. Not all the plants you may search for that you'll be seeing, that might be seen here. Yeah, because these are plants peculiar for India. Of course, we still have most of them in Nigeria. So let's look at for ginger. Let's say I want to work on ginger, Zignibe officinale. So you just click on ginger. You can just search ginger. So this is showing us the platform for ginger. This is the platform for ginger, which Hello? Is there a question? Okay. So when you scroll down now, this cluster here that is moving is actually showing us the how large the bioactive compounds that have been stored in this database. So you can just scroll down to see how many of the compounds are here. So here we have 531 entries. That is 531 compounds stored in this database for ginger. Now, there's not just stored the only the plant. They also stored with other information, like we have been saying, that chemoinformatics is all about getting information about a chemical data, about a chemical structure. Now you can see that this is all ginger. Now, very important, plant parts. I'm starting with phytochemical database. That's what we'll be doing today. Now, plant parts. So you should take note of the plant parts. This is area part. I can say show 100 first. This is showing 10. I can say show first 100. So I'm seeing, so first 100 will be showing here. So all these parts are area parts. Then we have seen flower. We have seen flower. So if you are designing a work with a plant, you don't just accumulate bioactive compounds of that plant. Say, I don't care about the parts. No, you must take note of the parts. So you must group these compounds according to the plant parts. So even if you downloaded literatures, like I said, that will be downloading 50 literatures per each plant. So even if you downloaded literature, you are going to arrange the bioactive compounds in those your literature based on the plant, based on the plant parts. So you may not arrange them based on solvents. Don't bother yourself based on the solvent used, but mostly based on the plant parts. So while downloading all the compounds found in leaf, you group them one part, you get them and keep them that these are compounds found in leaf. All the compounds found in the stem from those your journals, you keep it. This is for my stem. Then the ones found in your roots, you just keep them. For flower, that's what you do for all. Even if you are doing characterization, of course you take note of the parts you are using. So the same way too, that this database, maybe our focus is on the leaf. That means we'll look for leaf, for the leaf part of that plant. And if your focus is on the flower, so you take compounds on the flower part of that plant. So now you can see their indents here. They gave their plant an identifier. So if I download this plant, it will not save with the name, it will save with this code. So that is the beauty. And if I search by that code, IMPHY 000448. So if I search by the code, you see, I can search by the code and it will recognize the code and bring up the compound. Can you
hear me now?
Yes, I can hear you. Do you have a question? Hello,
No, continue.
Alright, so you can actually search by this code. I just typed the code and you see it's sorted out the compounds and brought the ones. Of course, it's one compound, but in different parts, area part, rhizome, and tuber, but all the same compound. Alright, so you can also decide to say, okay, now this is the reference. ISBN telling you from a textbook, while DOI is telling you from a journal. So if I open this link, you're going to see the source, the journal source, where they got this bioactive compound they use here. So that is a very wonderful one. But then what is my goal here? Why are we here? We are here, one, to gather the compounds found in my plant. So you can decide to download from this place. So I can download from here. Just quickly, if I click on this compound, if I click on the compound, it will take me to the platform of that compound. So this is a very nice database. It will take me into the platform of the ginger glycolipid B. So here you cannot get informations peculiar to this compound, to the ginger glycolipid B. You can get the summary of the structure, the physiochemical properties of this compound, the drug likeness of this compound, the admets, and the descriptors of this compound. So one thing about this database is that they always reference their source, which is very important. So this is one of the journal they consulted in their work, antimicrobial activity of some essential oils against Streptococcus. So in this journal they had some bioactive compounds from ginger or Z officinale. So they had 1,8-cinyl, neral, geranel. So from ginger. So and that is what we are going to do. And I know we are ready for that task. We are really ready for that task. So I can easily either download from here. Just scroll down, you will see chemical structure download. So which format do you want to download? I can download 3D. So you see that these people had 2D and 3D. They had 2D in mole, 2D in mode 2, 2D in SDF. They had 3D in mole, different format, and all these formats are found in ChemDraw. So while building our own, they also found in ChemDraw. So we are not just learning how to use this database, but we're also going to get exposed to build our own database for Nigeria, which we'll just try to see our best in doing that. So if once I click on 3D SDF, it will download, but it will not download with their index. So it will download with their own index. So look at it. It has downloaded with their own index, of course. So this is IMPHY 000448. So it has downloaded. So what kind of information can I get here other than downloading the structure? Please, meanwhile, the best platform to download structure is PubChem, because most publications, most authors, most journal publications, we want to see the PubChem CID. So but this one downloaded with their own code, which they may not really approve it. So what you will do if you want to download them with PubChem, what you'll be doing is to open PubChem and be copying them one after the other. You copy from here, you go to PubChem, you open your PubChem. So what you do is just copy the names from this database, then go to PubChem and download in PubChem, because PubChem is the most recognized database for chemoinformatics. So once you come to PubChem, you paste the name of that compound and download the structure. It will be very stressful. It will be very stressful, very stressful for you. I bet you it will be very stressful, because you'll be doing it one after the other to get their structure. So that is it here. Then you can now click on this CID. I'm showing you how to now download it from PubChem. You just copy the name of the structure from the impact, and then you go to PubChem and you download from PubChem. So I can come to download here in my PubChem, and there is no 2D. So this compound does not have 2D in it does not have 3D in PubChem. What it does is that it has just 2D, but it will download with the PubChem CID. So it means whichever one you want. It's just that the CID, the code for Indian is not common. The idea is just to use it and gather bioactive compounds. So, and as we proceed to molecular docking, we don't work with 2D structure. So that means we are going to learn how to convert our 2D structures into 3D. That will be under molecular docking using OpenBarbell for ligand preparation. Okay, I want to know, are you following up? Because I'm not used to just talking like that. Are you following up?
Yes, we are here.
All right. So so you can just be copying and be pasting in your PubChem and be downloading one after the other, depending on the plant parts you want to study on. So you don't just download everything. Even if you're downloading everything, then you download base. You can say, okay, let me download the fruits, the compounds in the fruits, and you save. Then let me download the compound in the leaf, then you save. So that the reason is this: since we want to identify a new drug from our plants, and most pharmaceutical industries are interested in plant-derived drugs. So if you claim that you got a compound and you did not actually note the plant part that compound is associated with, they will ask you, okay, which part of this plant has this compound? You begin to speak in tongues, and then even if you forge and say, okay, it is from the leaf, they would like to perform isolation. They would like to see if they can isolate that compound from the leaf, just as you have said that it is from the leaf. So they would like to see if they can isolate it from the leaf. So that is why while you are mining your data for plant chemicals, you take note of the part for reproducibility, for the sake of reproducibility. Even if your idea is to formulate a herbal product, even if the idea is to formulate a herbal product for the plant, you still need to know the plant parts that has the bioactive compounds you are working on that gave the best result. You cannot go and formulate a herbal product with the leaf, while the compound that gave that best result was in the roots. So that means you are formulating wrong. So that's the essence why even if you are using database mining or literature mining, you take note of the plant parts you are working on. So let me quickly come back to any of them. I want to show you some information you can get in this end part. Okay, so this is the summary. So here you see that I'll take note. You see that this place are interrelated. So you are seeing CID. CID is from PubChem, ChemBL code. So these are other database. So when they build this database, they have to also link it. So if I click here, it will take me to PubChem, because this is PubChem CID. If I click here, it will take me to ChemBL. So they were linked. Because you have to source for other database. Using extraction and literature mining cannot be able to help you to build a database. You have to check for other database that will give you information that you need, combine them and build. But while building, since you collected data from this database, you have to reference them by linking them direct to your own database. So by clicking here, it's taking me to PubChem. While this one is taking me to 10BL. Alright. So another thing we can get from here is the SMILE code. So the SMILE code is here, very important. The inch code, the inch code, then the scaffold and all the rest. Then the download. Then we click on physiochemical properties. This one has very large physiochemical properties. Here the tool they use is RD kit. RD kit is another chemoinformatics software. So look at the molecular weights, the log P, the TPSA, the number of hydrogen bond acceptors, number of hydrogen bond donor, number of carbon atoms, number of heavy atoms, number of heteroatoms. These are the physiochemical properties of that compound. As very large, very large. So what do you want to get depending on your interest? Drug likeness. This is for the drug likeness, the ability of this compound to be like a drug, the potential to be like a drug. Lipid violation, there is no violation, so it passed Lipid. Goes rule violation, one violation, so it failed. Goes rule. Verbal rule is good. Hidden rule is good. GSK rule is good. PZ rule bad, so it failed. PZ rule and other informations you can get. Then ADMET, which is talking about the pharmacokinetics, the absorption, the distribution, the metabolism, the excretion, and the toxicity. Now you are seeing that the tools where they got this information from is from a Swiss ADMET. So they are referencing Swiss ADMET here. The bioavailability score, the solubility. So these are informations that one can get from MPAT. The descriptors, this one's choke. Their descriptor is more than 1,000. I've explained about chemical descriptors. They are numerical parameters of your structure. Those features, those are characteristics of your structures, but in figure. Like you can describe your height in figure, describe your color in figure, describe your shape in figure using figure. That is chemical descriptors. So here it has about 1,875 chemical descriptors of that structure. Number of acid, number of LP, AMR with their description. Very, very good. In fact, PubChem does not even have such kind of description like this. So it does not have this kind of description. It's all your choice. What do you want to do? What do you want to do? Actually, this site was built by the Institute of Mathematical Science. Very interesting. How which Hendep can come up with something like this. It will be very good. Then the predicted human target. That compound limonene, you can check the possible target that this compound can attack in the body. So we're able to see 4 genes. This is the 4 genes, the 4 targets. All these are gene code CYP2C9. So these are gene code, and all this we are gotten from Stitch. Stitch is one of the software or database used in a network pharmacology to predict disease targets, to predict a drug target in the body. So that is for that. So these are the informations you can get from your MPAT under phytochemical search. Now we searched by the name of the plant. You can also search still under phytochemical. You can search based on the phytochemical of interest, but these ones are minor. With your time, you can look at them. Another thing I want to show you is the therapeutic the therapeutic use. So we can use impact to also check for the possible disease that my plant can treat. So probably, I don't know, I will just come select my plant. I will select my plant. Once you have clicked on this drop down, just give it a time. The plant will pop out. So you can now select it or type in the name of the plant of your interest. You can it's taking a bit time to pop out. Let's just give it a little time. Okay, so which plants? Let's still search our ginger. Let's see my ginger. What kind of disease can my ginger treat? You get it from here.
So, uh, good evening, everybody. So sorry for coming late.
Yeah, give me some.
Is it through the yes? Sorry, I just want to ask a question.
Yeah.
Is it Google search? You are typing the okay.
Yes. Yeah, you can
It's on
type
Google
it.
search.
Yes, they are online. They are web servers. Just type impact database in
Okay.
your
What
browser.
is the site?
Yes, it's a site.
Okay,
So
impact
even if you are using Chrome,
database.
yes, impact database. IMPPAT.
Okay.
All right, thank you, sir.
IMPP8.
PPAT.
Okay.
All right, thank you, sir. So these are the disease that ginger can be able to treat. So this is a database. That is just the idea. This now with the parts, they are still taking note of the parts. So the rhizome, which is what we often use, can cure abdominal pain, anemia, anorexia, anti-emetic, antifungal agent, anti-HIV. So if you have a plant and you don't know the actual target you want to use, the disease that you can actually use it to cure, you can now come to impact and it will give you a whole lot of informations. Now you can still choose the disease by yourself and say, okay, I want to see plant that can cure a given disease. So you can choose ulcer, then it will provide you the plant that can cure ulcer. So if I click on ulcer under the second option, it will also provide me the plant that can be used for the treatment of ulcer. So here for the treatment of ulcer, I am seeing Abis pindor, Abus precatoris. So I'm seeing different plants that can be used for the treatment of ulcer. So it enables your research to be very easy. So are you working on cancer and you want to know plants that can treat cancer? Just choose cancer. Just choose cancer and it will pop out the plant, because this is not AI. Because I suppose we start saying this is AI generated. It's not AI. It was manually created. So it was not linked with any artificial intelligent platform. And this is manually created from scientific data. And it's valid. Because they are referencing their source. So it's very much valid. Alright, so at this point I would like to welcome your questions on empaths. We have done so much, so if you have your questions you can do well to ask while I check the time, if we can move to the next session.
Yeah, I have a small question. We have seen how we can use this impact. But my question here is, how do some of these plants, their names are being written in scientific
Yes,
way.
scientific name. Yeah.
So how do you visualize the plant? Like, if you want to go and identify it, is there any way they can give you so that you'll be able to know, okay, this is the exact plant they are talking about?
Okay, our
Is there
impact.
any way to generate the image of the plant?
Okay, okay. Impact does not provide the pictorial representation of the plant. So maybe what you can just do is copy the name from the one you want to work on or work with. Copy the name and go to your Google and paste so that you can get the picture of the plant. Then look out for the location from Google. So such informations we are not provided in impact. So but with the name you can now do whatever you want to do. Just like me, I in as much as I can lay hands on the scientific name of a plant, then forget it. I can search for it. And the way science is now, you don't need to have the plant handy. You don't need to start looking for the plant. We can use this impact now. We'll just get a lot of bioactive compounds without even going to look for the plant. We can also go online, do literature mining without even looking for where the plant is in Nigeria. But it's also important we look for the plant so that we can do our personal characterization to support our data. But that era of lab work has gone because there are a lot of it online. There are a lot of work has been done and published. So we are just gathering this work that has been published. That is what American is doing. That's what India did. We in Nigeria we are going to do characterization GCMS phytochemistry, and we want to publish in a Scopus Index journal. We push our work because of promotion. We push our work to American Chemical Society. I want to publish there, and you will publish. And what they are doing is that they are curating our data. They are curating this data, building database. Now we will still pay to access with our own money. Why those informations are your information. So sorry, I've talked more than what you asked. So just copy the name and go to Google and paste so you can get the structure, the image of that plant for identification, and the location where necessary. All right, thank you. Okay, any more question?
What's the question?
All right,
Yes, please.
yeah, go ahead.
We have like 10 minutes.
Yeah, yeah.
So, I just wanted to know, like, if we're going to use this impact, does it mean that we are going to manually put in all those details one after the other, or we are just going to put a link to maybe PubChem or a different site, or we are going to write all those details one after the other?
Okay, do you mean building your own database?
Do you understand the
Is it
question?
for building our own database or for downloading the
No,
structure?
I'm saying like if you are going to, yes, if you are going to build, no, not if you are building now
Okay, yes,
your own database.
yes. We are going to put.
Uh,
We'll copy the link.
so it means you're going to,
We'll take the link from. We'll still put the structure in our own. We'll put the structure in our own as if we are the one that has it, but we'll still also reference them with their link. So we'll not just put only their link, we'll put our own structure. But since our structure is found in other database, we're also going to link up those database that has the structure. I don't know if you understand what I'm saying. What I'm saying is the structure will appear in our own database, but we are going to search if this our structure is also found in other database.
But the other details will be a link from the other
Yes,
side.
yes, just a link from the other side. Yes. Yes, we'll just link it, a link from the other side.